Welcome to Homework Lib.
So for this question, we are considering the reaction of chromium hydroxide 3 as a solid that is going to get dissolved into chromium 3 plus in aqueous solution plus 3 equivalents of OH minus in aqueous solution. So the first thing that we need to know is going to be the solubility product constant for this solid, which turns out to be 6.3 times 10 to the minus 31. So we can do our ice table, and we can as well remember that the solubility product constant is given by the concentration of chromium 3 plus times the concentration of OH minus cube. Okay, so in our ice table, everything is going to be in molarities because that is the way that KSP is going to be calculated. First of all, we are going to have the solid. The solid does not we do not take it into account because it's a pure substance, but the amount of change that it's going to have is minus S, where S is the solubility of this compound. That is the portion of the solid that goes into solution. So here we have a one-to-one correspondence, so we're going to add plus S, and in the case of OH minus, we are going to have plus 3S. So at equilibrium, the solid, it doesn't matter for us, but we're going to have S and 3S for the concentration of chromium 3 plus and for hydroxide minus. Okay, this means that our KSP, we can write it down as S times 3S cubed, which turns out to be 27S to the 4. Thus, if we solve for S, that is the solubility for this product, we will be able to calculate the amount of mass of the chromium hydroxide that is going to get dissolved in solution. And we're also going to be able to calculate the concentration of the hydroxide ion when we are in a saturated cobalt 3 hydroxide solution. Okay? So for solubility, the result it is going to be the value for KSP divided by 27 elevated to the 1/4, which is 6.3 times 10 to the minus 31. You should check up that value because some tables differ a little bit. The result should be in the same order of magnitude, but the actual number may change a little bit depending on the reference that the table that you're using employs. And the result for that is a solubility of 1.236 times 10 to the minus 8 molar. So that is the amount that is going to get dissolved. We can also use this amount to know the concentration of OH minus. The concentration of OH minus directly, it is going to be 3 times S, right? So the concentration of a saturated solution of this is going to be 3.708 times 10 to the minus 8 molar. So that is the answer for the second part of the question. As for the first part, we are asked about how much is dissolved in 150 milliliters of a saturated solution. So that amount is going to be equal to S, which is, as we said, 1.236 times 10 to the minus 8 molar, which we need to remember that is mole per liter. We can find the amount of moles that we have simply by multiplying by the volume. In this case, 150 milliliters, which turns out to be 150 times 10 to the minus 3 liters, right? Just to take the conversion directly over there. So the amount of mole that we're going to have, it's going to be 1.854 times 10 to the minus 4 mole. Mole of what? In this case, we're dealing with mole of chromium hydroxide. And now simply we can use the molar mass in order to get the result. So the amount of mass of chromium hydroxide is going to be the amount of mole times the molar mass, or the molecular weight, right? So that amount of mass is going to be a result of the amount of mole that would be in 150 milliliters sorry, this is times 10 to the minus 9. The cursor didn't got the correct. Okay, times 10 to the minus 9 mole multiplied by the molecular weight, which is 103 grams per mole. So our result in grams is that 1.9 times 10 to the minus 7 grams of chromium hydroxide are going to be dissolved in our saturated solution of 150 milliliters.